Cheers.
Well, thank you. Welcome, everyone. I'm going to speak today about making IoT safer and demonstrate some open source software on a Raspberry Pi. I have 2 Raspberry Pis here, both of which I'll give away along with the lights that go with them, along with a couple of other props. My Twitter handle is @dsparrell, so please do me a favor and tweet photos, particularly ones with blinky lights and me in the picture, and you might win one of them at the end if you have the best photo. So my tagline is think evilly, act ethically. There's a hacker conference called SmooCon where they give all the attendees these things called smoo balls, and you throw them at the speaker if you don't like what they're saying. You guys don't have one. I do have one, so pay attention. But the reason I use it is I'm going to use this wood grenade later in the talk, and I think the internet used to be like the smoo ball. It used to be, if I threw it at you, it's annoying, but it's not going to hurt you. Okay? If I throw this wood grenade at you, it's going to hurt you. And the internet is more and more that way, that people actually get hurt, and that's what I'll be talking about. So we need to worry about safety. I'm going to use this little Chinese takeaway box to takeaways when I say things I think you need to remember. So think evilly, act ethically. That's the first takeaway. Besides takeaways, I'm going to have some giveaways. The blinky lights that you see, I'm going to give away to basically either good photos or questions at the end. So I know it's a lot of talks. People are real quiet. They don't ask questions. Ask questions. You might win a Raspberry Pi. We'll see. So one of the subtitles to the talk, if you noticed it, was where bits and bytes meets flesh and blood. Bits and bytes, software, particularly software in the Internet of Things. Things like the electric grid, things like cars, planes, trains, things like industrial control systems, robots, and in healthcare. Now by meets flesh and blood, I mean accidents happen. And the accidents might not even be accidental, okay? They might be hackers doing things on purpose. And people get hurt, and people die. And that's why safety is important. Now, I mentioned this wood grenade. I like to split wood. When I split wood, it's a lot easier with this wood grenade. And the reason is you start it in one of these cracks, and then use it to break out the wood. And when I do my hacking in cyber, I find that it's also easiest to go in through the cracks. Now, why am I stating this obvious fact? Okay, because the easiest way to find physical safety issues in cyber physical systems is to look at the previous safety issues. So we're going to do a little bit of that. So this is the Deepwater Horizon disaster, occurred in 2010, generally called the BP Gulf oil spill. And there were basically 8 failures involved in this. And none of them were caused by a cyber attack, but all of them could have been caused by a cyber attack. Basically, if you look at what happened, it's basically a set of algorithms running a bunch of actuators and a bunch of sensors with a bunch of third-party parts, i.e. an awful lot like an IoT system. Trains have been hacked. Philadelphia subway, locally here in the San Francisco area, BART got hacked into. These were not done by hackers, or those were done by hackers. This train wreck was not caused by a hacker, but it could have been, okay? To actually prevent train wrecks like this, they're now putting computer-controlled devices on trains. Things that could be used to prevent crashes, if used maliciously, can actually be used to cause crashes. People always talk about the electric grid and how people hack into that, so I like to use a different utility. I like to use natural gas. And again, what I'm going to talk about did not happen by hackers, but all of the things that did cause what I'm going to show could have been done by hackers. It's possible to do that. In 2018, in a couple towns in Massachusetts, the local gas company made a mistake. They overpressured their gas lines. And it was due to some faulty decision making, some faulty actuators, and some faulty sensors. Again, all the things that are in IoT systems. Okay? And what happens when you overpressure a gas line is gas leaks. Gas leaks explodes, okay? And it didn't just happen in a house. All the red dots were houses that burned down. All the yellow dots are houses that, fortunately, the spark didn't go out. They still had the gas. It's just they managed to evacuate and make sure there were no sparks. But it was a very serious event. And again, it wasn't caused by hackers, but could have been. Switching over to medical, the patient on the gurney there is a friend of mine, Bo Woods, and they took an unsuspecting doctor and did what in medical terms is called a simulation and say, hey, let's simulate a heart attack and you show what's going to be done. And what they did is they faux killed their patient by hacking into the infusion pump, and it totally, it actually caused the patient to faux die. Now, this made headlines, okay, and it's sort of a big deal, but it's just theoretical. No one's actually died, right? Well, it turns out I would argue with that point. I think people have died, and so let me digress for a moment, give some background. This is a journal article from the New England Journal of Medicine. It compares mortality rates around marathons because marathons delay ambulances. And there are basically 4 points: hospitals near the marathon, hospitals not near the marathon, on marathon days, not on marathon days. And the important point is, on marathon days in the affected hospitals, an average 4-minute delay caused a 3% rise in mortality. That means out of every 100 ambulance rides, 3 people died because of this. And that's a fairly short delay. Okay, so what's this have to do with cyber? A major LA hospital, Hollywood Presbyterian, was offline for days. Think LA traffic. Okay, I can't do an epidemiology study to prove that anybody died here like you can with marathons because there's a lot of them. But I would maintain that people died in LA due to this. And there are people now doing studies finding that people did die in the United Kingdom when WannaCry hit and took out 1/4 of the hospital. Some for several hours, the length of a marathon, and some for several days. So it's, again, safe to say that people are actually dying due to hackers. So I'm a cyber guy, so we always try and scare people. That's what I just did. I made use of what we call FUD, fear, uncertainty, and doubt. But turns out FUD is not a good long-term motivator for humans. It's water off a duck, as is shown here. It does short-circuit your brain and makes you not make logical decisions, which is why vendors use it so much. But we need to make more intelligent security decisions based on actual measuring business risks, and that's what I'll be talking about. Because we need to do that on the IoT devices that are going to be controlling all this stuff. So this is from the movie Jerry Maguire, Show Me the Money. It turns out money is pretty good in getting people to make business decisions. And you can do that with security if you use the right type of math. And the right type of math is in books like this one. I'm going to give away one of these at the end too. It is a textbook, so it reads a little bit like a textbook, but it's got a lot of really good concepts in it. Too much to cover. But one is there's a lot of work in other fields that cybersecurity can take advantage of and does in these books that I'm going to show you here. And one of the particular tools that's useful, I give in all my talks, I think that absolutely everybody should know how to do this. It's just engineering 101 in anything to do with software. And that's something called the loss exceedance curve. And that's because it's a probabilistic thing on whether something bad's going to happen. And so there's probability on the one axis and money on the other axis, and it's for a fixed period of time, like a year. So for example, there's a 90% chance of this particular company losing at least $10,000 in the next year. It's a log curve, so there's a 50% chance, so the most likely view, they're going to lose around $5 million. And there's a small probability of a high impact event that they'd lose $110 million. Now these curves can be used for, you don't have to do them perfectly, because what you're going to use them is going to use them for decision making and comparing curves. So some vendor shows up with a Blinky box that says it's going to save you a lot of money, because if you spend $500,000 with them, then you're going to save $5 million or $4.5 million. Then you say that's very good. That's good math. I should do that. That's a good ROI. However, in this particular case, it's interesting because you're putting all your eggs in that particular basket. You actually increase the chance from 1% to 10% of a catastrophic failure. So maybe you not want to save quite that much money, take some of that money and use it to move that lower line, reinvert it back. Another book that's very useful in this field, a whole concept, there's a nonprofit called the FAIR Institute, that this is on something called FAIR, which is Factor Analysis of Information Risk. There's actually an open group standard on it, and I'm going to give that book away also. This quote is particularly important because what it's basically saying is we in the cybersecurity industry are not doing very good at our jobs. Okay, we're making economically incorrect decisions based on FUD. We should be using this sort of real math and real engineering stuff. And I won't go into a lot of the details of FAIR because just like in the other book, this is a semester course kind of thing. But basically what you do is you take big problems, break them down into little problems, take the little problems, break them down into parts. So a scenario like analyze the risk of criminals extorting money from a hospital by installing ransomware on our MRI machines. You then figure out a bunch of things associated with that, get a bunch of data, plug it into, use statistical methods, and sum the whole thing up, and you get your whole enterprise loss exceedance curve that we talked about before. Checking my colored lights here to see if I'm on track. This is a really expensive talk timer. Another standard that I think is really important was written by lawyers. This is actually a law standard. It's called Duty of Care Risk Analysis, or DOCRA. And it's looking at cybersecurity in an enterprise from the way a judge would look at it if you were in court. Because, for example, are you negligent if a hacker either unintentionally or intentionally causes someone to die due to your software? Are you liable or not? That's the kind of question the judge is going to ask, and this helps you work through that to help you decide to plug in all those models, what is the right amount of money to spend on your cybersecurity. So the sort of catchy takeaway from this is FAIR, not FUD. But what this means is you should be using quantitative risk analysis, things like those loss exceedance curves, to determine what a reasonable business risk is. Now let's talk about some reasonable things to do to reduce those risks, to make IoT safer. So I'm a member of this thing called I Am the Cavalry, which is a volunteer group on basically trying to make IoT things safer. And they come up with catchy phrases like, where bits and bytes meets flesh and blood. And this one, if you can't protect it, don't connect it. Okay? And that's sort of the theme of my entire talk. So looking wider than the world of IoT, the CISQ, the Consortium for Information and Software Quality, has this manifesto that they think every CEO of any company should sign. And it's a base of 5 simple principles on making, producing and using quality, secure, safe products. Okay? I maintain that if all companies did this, we in this community would be much bigger and sell more stuff because we play very well into these characteristics. I'm going to talk some about item 3, traceable properties, some about item 4, proactive defense, and basically my whole talk's about item 5, building resilient and safe operations. You ever heard the expression, don't buy a pig in a poke? Okay, this is not about don't buy pork in an Asian lunch bowl, okay? A poke is a burlap bag. So what this is saying is don't buy something that you don't know what it is and what's in it. So what that means is don't buy most software, okay? Because we don't know what's in it, okay? So going back to the DOCRA, is it reasonable to either sell or buy software that you don't know what's in it? The answer most people would answer is no, yet we all do it. And recall the CISQ number 3 was traceable system components, okay? So that leads to my next topic, which is something called an SBOM, a software bill of materials. It's about providing software transparency about all the software in your system. So the FDA recently, this has really gotten hot lately because the FDA put out what's called pre-market guidance to all medical device manufacturers and said, you don't just have to tell me what hardware you have to tell me what software you have. You have to have one of these SBOMs. And the car industry was also looking at one, and the DoD already had one. So the Department of Commerce stepped in and said, hey, we got to homogenize all this stuff. And the NTIA, which is part of the Department of Commerce, formed this what they call a multi-stakeholder group, of which I'm a member, to come up with, hey, how do we do this stuff? And there's some really good material at that. One of the takeaways is nta.gov/SBOM. So what am I talking about when I say a software bill of materials? Basically, it's an ingredients list. Okay, this is an ingredients list off a bottle of shampoo in my hotel room. Now, all analogies are wrong. Some are useful. That's a sort of first-order analogy, not as good as it could be. This one's a little bit better analogy, okay? It's the parts of the gun are made up of other parts, which are then made up of other parts. There's sort of a recursive nature to it, okay? As well as it sort of shows how they fit together. It's not just a list, it's how the stuff goes together. And that's much more useful in software. As part of this NTIA group that I'm a part of, they're doing, they've already done a phase 1 proof of concept, and they're now doing a phase 2 proof of concept where a bunch of medical device manufacturers got together with a bunch of hospitals and lots of lawyers and lots of NDAs and other stuff like that, and sort of tried out hey, will this actually help everybody? Okay, and the answer is yes, it helps both sides. It's a useful thing to do, and that gets into looking at the SBOM from different perspectives. So let me talk a little bit about that. So one of the perspectives is who makes the software. So sort of we've officially defined the term as the producer of the software is one group of stakeholders. Another group of stakeholders is the people who choose software. This is not just the people who choose the end product like that infusion pump, but it's also the software developers who are making that infusion pump who choose other components that are part of it. So you can sort of look both ways. You can be choose towards your supplier, but produce towards your customer. And then of course there's the ones everyone always forget, which is the operators, the people who actually use the software. And we did studies, we've determined that all three of these benefit from having SBOMs. And there's a lot of benefits, and again, I can't go over all the benefits in all of the perspectives, but it turns out all of the benefits apply to all of the perspectives. It's cheaper, it's more secure, you handle all your licensing issues correctly, you handle all your compliance issues correctly, and if you happen to have a high assurance application, and I would argue all IoT cyber physical safety devices have a safety aspect to them, so they should be high assurance, okay, you'll benefit from knowing what software you're actually using. So let me switch gears a little bit and talk about the CISQ number 4, which is you should automate your, or you should, the answer to it is you should automate your defenses. And why should you do that? So this is a study that Johns Hopkins University Applied Physics Lab did on automating their cyber defense systems using some standards I'm going to talk about on the next slide. And the key result of this, okay, is they got a 2 order of magnitude decrease in how long the hackers were in. Now they had a pretty good system already. The hackers were usually in their system only for a couple weeks. Most companies, hackers are in for years before they get caught. But that couple weeks they reduced down to minutes. Well, hackers can't do much damage in a couple minutes. They can do a lot of damage in weeks. So what that does is that gives you the data to plug into those models I talked about earlier about, is it worth doing this stuff to decrease your risk? Yes, because it decreases the damage done, decreases the probability, and decreases the amount of damage. So that's the kind of stuff you should plug into FAIR and into Hubbard-Searson. So what they actually did, I'm going to talk about some of the standards, but use this scenario, could apply to anything, is you guys write some software, hopefully, because I've now preached at you about SBOMs. You make SBOMs, so that's not actually essential for the scenario. Like most software, there probably will eventually be some vulnerabilities. If there is a vulnerability, the person most likely discovered is probably going to be a hacker, okay? And the hacker is going to exploit it. But the good news is exploits tend to leave these things called indicators, and there's security systems that discover indicators. But a problem the industry has is we don't share indicators very well at all. We don't even share them between 2 vendors in the same, a company using 2 vendor products from 2 different vendors. They don't even share them in their own company, let alone sharing between companies. It's how it used to be. We're getting much better at it, and that's why we have standards like STIX and TAXII on basically how to share this kind of threat information. Now, once you've shared it, oh great, I know I'm being hacked. You still have to do something about it, okay? And what you do about it's called a course of action. And again, once somebody else figures out the right way to do something, you want to share that information across the defense community. So there's some standards on that, and it's called CACAO, I guess because the guy who came up with it likes chocolate, but it's this big long acronym that's got course of action in it. But again, even having the plan isn't good enough. You actually got to go do something. You got to talk to all your security boxes. And again, they tend to speak different languages, and firewall's been around since forever, and every single one has a different thing. So there's another standards activity involved called OpenC2, associated with how to control security devices using a common command and control language. And believe it or not, these Blinky boxes are controlled by OpenC2 and the open source software that I'll be talking about in a minute. And I'm involved in all these standards and actually chair the OpenC2 committee, so happy to talk for hours at length to anybody who wants to know more about any of this stuff. Let's get to a little bit closer to everyone's heart. Why should we use an OTP? OTP for me stands for one tough platform, okay? Let it fail was a big step towards let it be hacked. So there's a lot of reasons why this plays very well in the IoT world. This is why OTP is so tough, the properties that make it so good. Remember that security is confidentiality, integrity, and availability. We're basically designed for availability. And the let it fail turns out to also be very good for integrity and confidentiality, because most software bugs, okay, that's basically what they're exploiting. You're exploiting the bug, and the let it fail aspect leaves less of the bugs exploitable. not zero, and you can still make design flaws just like anyone else can do that can hurt your security. So you should be reading the work of the, which I'll cover on a slide, or well, I'll just get to it. So you should be making use of your resources like the Erlang Ecosystem Foundation Security Working Groups document that Bram talked about yesterday. You should be using SBOMs, and there's actually tools, again, that Bram wrote associated with both Mix and Rebar to help you do that. There's some secure coding practice guidelines. There's lots of talks at this conference on it, almost all of which mention make use of OAuth. There's, again, a lot of work that's being done that you can learn how to design your code more securely. And again, Bram gave a talk yesterday. If you didn't see it yesterday, go listen to it on the video. The different HEF packages was also a very good talk. There's a talk later today on resiliency of the BEAM that's good. And if you're really desperate, you can look up my Let It Be Hacked talk from a previous one of these conferences. Again, this is a takeaway, make use of your resources. So let's get to actually touching stuff. So I called it Blinky Haha. That's why it's in red, because it looks sort of like Benny Haha. But the reason it's Blinky Haha is because Blinky is the sort of hello world of the IoT world. You blink an LED light. And Haha is the hello world of the OpenC2 world, that command and control thing I talked about before. It's for HTTPS, API, hello world actuator is what Haha stands for. And again, these devices are running it. You can say hello to them and they'll say world back to you over OpenC2. It's all open source. It makes use of nerves. It's running nerves. It's running a set of libraries called Blink Chain. That's what makes the blinky lights. It lets you change the timers so that I can tell that I'm blue now, which is, I think I'm still on track. And it makes use of Haha. Now, Haha is again a particular actuator from over in the OpenC2 world. One of the things that OpenC2 allows you to do is also query for SBOMs. So we make use of, Phoenix to run the Haha. And then that's a sort of aside, but I need to clean it up some. But there's a website where I'm going to sort of go through the SBOM by example of how to create the SBOM for all this stuff. And then we make use of the Rebar 3 and Mix packages that create the SBOMs. And I'm going to spend a little bit more time talking about the SBOMs a little bit. And a sort of gratuitous takeaway from all this stuff is I hate it when people say FOSS, free open source software. All of this is open source software, it's not free. If you use open source, then you're taking advantage of the fact that somebody else created it. So yes, you are saving that cost. You shouldn't take advantage of the fact that someone else is maintaining it and someone else is patching it. You should be contributing there, and if nothing else, you should be doing the patches and following what's going on there. So I maintain it's not free. Let me go over SBOMs a little bit. So creating SBOMs is hard, okay? The first time, when somebody's done it, because again, the issue is usually you're using software which uses some software, which uses some software, which uses some software. So that first time is hard, but once you sort of get over that hump, it's easier because you sort of only have to do it for your own stuff. And again, the build tools will help you with that. And that's where I'm going to sort of go through some of those examples at the bottom there. And the other thing I'm going to do at this point is attempt to run a screen up there from over here, which might get interesting, and get into Postman. How do I get it to switch screens? It's just hitting the top. Oh, I think I'm going to have to. Full screen. There, I'm out of screen. All right. Because I can see it on my screen, but that isn't helping you guys at all. All right. So this particular Blinky box, which is an 8x8 matrix controlled by a Raspberry Pi Zero, So the Raspberry Pi is smaller than the Blinky box, and the reason for this is just because it's so bright. It was like blinding me when I was practicing. And it's running Nerves, which is running the Blinky haha code, which both has the Blinky light code and the haha code. Postman's a good tool to just practice. Hey, send a API or HTTP command to something. Unfortunately, I have them pre-set up because I couldn't type facing the wrong way like I am here. But this particular one is hooked into my computer over the USB. Nerves has this sort of fake out, but make both boxes think they have an Ethernet running over the USB. It's got an IP address and everything. And if this works, and I didn't screw it up by changing my networking earlier, I can send a particular command. It might be a little small. Let's see, I don't know if command plus works here. It makes it a little bigger. I don't know if that helped much. But I'm sending some JSON, which is in the OpenC2 query language, which basically is doing a query against a target called hello, and it's returning a response that I guess you can't see because I guess I made the screen too small, so I guess I got to go back to doing this. It says hello world, which is now really small because I made everything smaller again. But again, that was a OpenC2 command sent from here that responded to here, running over a particular type of API. And I can send it other OpenC2 commands, like tell me what version of OpenC2 you're using. I can send it. This is really hard running a mouse backwards. A query command that says, hey, tell me the commands that you accept. That's part of a discovery command. And then the one I'll say that's most interesting from this is a command I hope becomes the hello world of IoT cybersecurity, which is the, hey, tell me what software you're running. So it's an OpenC2 query that actually I got to go up here to see the body, that basically says, give me your SBOM, and it responds with, I can make this bigger. No, that's what you use this for. Okay, that's what you take this answer back and say, okay, now let me look up and see, do I need to patch because I haven't done whatever. And it tells you a little bit about the SBOM, and it gives you this big, huge base64 encoded thing that if you decoded it, which I won't bother doing here, you'd end up with this big XML manifest that's in a particularly correct format that the SBOM people like called Cyclone DX. And that was all done thanks to Bram's code. So now let me see if I can switch back to presentation mode. Thought I did it down there. Oh, I did. Wonderful. And these are turning red, so that's good. We're getting further into the talk. I did need to get to these were to warn me, sort of, hey, I should be at this point by now, so that's good. Get back down to here. All right. So summing up, what have I showed you? What are the takeaways from this talk? First is think evilly, act ethically. I happen to be really good at this. I don't know why. A lot of people aren't. They think no one would ever do this kind of thing. But you do need to look at your code with like a hacker would look at it. But just look at it that way. Don't actually do the bad things. Do the things to fix it. OTP, one tough platform. Make use of it. Okay. Really important. Follow this web page. This is the EEF, the Erlang Ecosystem Foundation Security Working Group page. Okay, it's got on it documents. We're just getting going. We want input from those. We have a lot of good stuff in this, but we want input on it because maybe we're not right. Maybe there are conditions we're not covering, and there's probably lots of stuff we left out. So we want everyone's input, and we hope this will grow by quite a lot. And we'll start putting references into, like we mentioned, OWASP and the other coding practices and these talks and stuff like that. So again, make use of the resources. You need to make the world safer. Make use of the quantitative risk analysis tools that are available. Make intelligent business decisions based on actual business risk. Maybe you don't have to patch everything. Not everything might matter. It really should be a trade-off. But you probably need to do more than you're doing is usually what happens when anyone does the analysis. So we mentioned before, when people do the intuitive, what do I think I should be doing in security, they're almost always wrong. And that's even security professionals like me. You really got to plug the data in to make the right decisions. Most important thing in the IoT world, if you can't protect it, don't connect it. If you have an MRI machine that was built 10 years ago, okay, and it wasn't built to be connected to the internet, and you connect it to the internet, almost certainly some hacker is going to take advantage of it. One of the top money makers in the hacker field now is ransomwaring hospitals. Okay, you'd think people wouldn't do that, but they do because it makes them a lot of money, because in general, the hospitals pay it because otherwise people die. If you produce software, make SBOMs. If you choose or operate software, make your suppliers make SBOMs. Automate your defenses. Use standards. Share with other defenders and be open about it. I always like to close with a quote from Dan Geer, who's one of the thought leaders in cybersecurity. There is never enough time, so thank you for yours. Here's all my contact info. This is a Prezi. It's available online. Feel free to use anything that you can take from anywhere. And now we get to the good stuff, which is the giveaways. So we have 2 books, a wood grenade, smooth ball. Anybody want the smooth ball? I'll throw that at anybody who wants it. Nobody cares.
All right. So.
All right. Make it get all the way over that way. I'm not throwing this one.
The audience that wants to come up and ask questions.
Yep. And remember, questions win you prizes, so it's good to ask questions. Let's see if we got anything. It's probably bad to, oh, good, you guys can't see my screen. I'm going to search Twitter real time and see what pictures we can see here. All right, I'm not fine. Oh, it's because I can't spell my own name. All right, I'm showing pictures I'm putting up there. All right, did anyone tweet any pictures? All right, how come I'm not finding them? Did you have code BeamFS in them? Yeah. Did you have @DSparrell in them? Yeah. All right, then I'm doing some. Oh wait, here's some. All right. All right, so Robert Brown. Who's Robert Brown? All right, you win a prize. See me at the end. There's one gone. Bram, that's you that did the exploding one. You go on. So Bram gets one too. So there's two of the 4 or 5 things gone. And first up question will be the third. We'll figure out order later. Will also be a prize. What's your question?
I don't work in IoT and I haven't worked with nerves, but in the previous presentation, there was the mention of Nerves Hub, and I'm basically a pretty conservative person. I don't personally own any smart fridge or smart anything, and don't want one.
Do you drive a car?
I do drive a car, but
Yeah.
it's a 2005.
Okay.
All right. Okay.
But anyway, your question.
So I was wondering about Nerves Hub as sort of a vector for doing very bad things. You know, if that's I'm just guessing that it's a way for you to bring down updates.
Again, you should do a quantitative risk analysis of your particular situation and determine what the threats are, okay, what their probabilities are, and what the best way to mitigate them is. The advantage of something like Nerves Hub is you don't have to send people out with USB, so you can update more often, okay? And there are things you can do to make it reasonably secure than not updating, for example, because that's your other choice. If you're trying to update all those pictures that, you're trying to update a tugboat on the Mississippi, it's not that easy to do unless you can get at it either remotely or physically. Usually remotely is better, so there's just ways you have to secure it. So you have to put thought into doing that correctly. But maybe you don't want to use the public Nerve Hubs. Maybe you want to build your own if you're a secure application. If they were using nerves in nuclear armaments, I don't think they are that I know of, but if they were, because I did work some in helping secure some of their stuff, they wouldn't use the public one. They'd have their own private one, and they'd put a lot of special, stuff around it, as well as they'd watch anybody trying to do it. You don't have to mitigate everything by stopping it. You can mitigate some things by just catching people doing it, and if you're something like the US government that has its resources, that you can do things back at them. We can't as normal people, but they can. So very good question. You're number 3, I guess. So three giveaways. I got 2 Raspberry Pis and 2 books and a wood grenade. So it's got to be at least another question out there.
Another question?
What do you see as the main difference between an SBOM and a project dependency tree where you can see all of the components that are needed?
So a project dependency tree is a type of SBOM, is one way to word it, okay? Does it have everything you need for all of the use cases is not necessarily true, and is it complete is also not necessarily true. Usually it doesn't go all the way down to what I call the leaf level. Usually it only goes a certain level in. Like if you're using, a particular Linux kernel, you just say Linux kernel whatever, and usually when people do that, they mean a lot more than just the Linux kernel. They mean about 9,000 things that go with it, and the 9,000 things that go with it each have their own version and their own thing, and a lot of the time the actual vulnerabilities or hacks are in that almost invisible, no one ever looks at and isn't on a list of things. So it may be you're good enough to do it, and it may not be. It depends a lot on your situation. But a good SBOM is machine readable, so it can be plugged into, like somebody mentioned, the tools are you vulnerable? Is there a vulnerable in your particular TLS you're using because they announced some new CVE yesterday or something? It's also, is it correct for your licensing needs? Does it have all the ties in it? There's, every one of those use cases has sort of a lot of, I'll call it metadata that goes with it that people, for those use cases, stick in the SBOM that you don't necessarily get from just knowing that it's, I don't know, or Phoenix is a good example. You say Phoenix version, I don't know, whatever version Phoenix is on now, you're talking a fair number of other piece parts that go with that. So it's a good start, and if you're looking at stuff like that, it's good, but you probably want to go further. And it might be it's good enough, and you just got to have the format conversion to turn it from whatever format you're using it into one of these things these other security tools can use or licensing tools can use or whatever. So good, you're number 4, you're winner number 4, and you get another question.
As a related one, if you get to a leaf that has its own SBOM, do you include that SBOM, or do you point it at there?
Huge argument in this study. Huge argument. The answer is it depends. Depends on your use case, depends on who you are. Having now tried to do it, it's actually really hard to do this stuff. I'd like to stop at that point. Just go, great, I've got the nerves. Good, Frank, you figure it out from here. I'm going to work with Frank to try and figure it out from here, because to actually get the data you need to do what you should be doing, you should probably know everything that's there, not just know I have one of those in there. You should actually know what's in it. Now, it might be good enough for many applications to just, for lack of a better term, the URL of where it is good enough. For those high assurance applications, if you have what's called a high provenance application, you not only want to know what the code is, you want to know what code got used to build it. Because as a hacker, the thing I love to take over is things like C compilers, okay? Because you have no clue. You think you're compiling your code, you're compiling my code. So, it depends on your application and the thread and everything else. Alrighty, another question? And I don't know how much time we have, because I'll need time to break down to
for context,
give away stuff.
I've worked with nerves for 3 years, and the product I was working on.
So you know way more about it than I do.
And the product I worked on had to be HIPAA compliant.
Yep.
And I've looked into all sorts of different command and control languages, and I haven't seen OpenCV2 before, so I'm curious what makes it secure. Is it the SBOM?
Well,
is there signing
its
involved?
job isn't to make it secure. Its job is to help you with security. Okay, so I worked for AT&T for 35 years. I retired 6 years ago as their Chief Security Architect, so I was in charge of basically how all the boxes talk to each other. And it drove me absolute bananas that firewalls were invented by a couple other friends of mine at Bell Labs back in 1991, and today every single firewall, and there's like 35 of them that just AT&T uses, okay, has a different command and control language. So OpenTSU's job is to try and make a vendor agnostic language so I can switch. I'm buying your box today, and I want to switch to your box tomorrow. When I was buying $1 million refrigerator sized boxes, I mean, they're going to last a while. It wasn't that big a deal if they use the same language. We're using the cloud now. I want to be able to hit carriage return and switch. I'm locked into vendors right and left because of this command language issue. So it's more an issue of, can we build those COA things? I was talking about the course of actions with, I don't want to build it for a Cisco firewall and then it doesn't work on a Palo Alto firewall. I want to build one that works on any firewall. So it's for stuff like that. It's not how you transport it and where you use it. Again, as a hacker, the absolute first thing I'd want to take control of would be the command and control network of the security system. So you have to secure that independently. It doesn't inherently do it. It's more so we speaking the same language.
Okay, so the purpose is just having a standard and also having auditing with it.
Having what?
Having some auditing, such as with the SBOM.
Oh yeah, and have it do things like give you an SBOM. In fact, one of the arguments we have is should SBOM be a required? There's some things that are required. If you say you're OpenC2 compliant, you got to at least answer the question, hey, what OpenC2 commands can you use? What profiles do you? Are you a firewall? Are you an IDS? What are you? We're making SBOM a profile. We actually argued maybe it should be just built in. You can't say you're compliant unless you give one. Then one said, yeah, but no one has one yet, so we can't do that, so no one will be compliant. So there's a chicken and egg issue. I'm hoping that years from now it'll be table stakes, but right now it's still a differentiator.
Thank you.
And OpenC2 is brand new. I mean, the first iteration of the first set of standards for the first types of security products just came out a few months ago. So it's not like they probably didn't exist when you were working there. All righty, well, thank you all. And prize winners, step over there, and I will disassemble everything and give them to people.
Thank you very much.